So I'm here with Michael Wolfe. We are attending the International Conference on Parallel Processing, where Michael just got a Test of Time award yesterday for some of the work that he did in loop optimization. So Michael, this is for students that are starting their career and perhaps looking into compilers. Why should they consider dedicating their time and effort to learn compilers?
So let me start by saying I have had a long career working on compilers, particularly compilers for parallel processors, back when parallel processors were rather new or quite rare. Now, of course, everything, your phone is a parallel processor. Now, a general thing about compilers. Compilers are the fusion of almost all of classical computer science. And by classical computer science, I mean the computer science I studied when I was a student at the University of Illinois. So things like programming languages. You have, in the compiler, you've got data structures, you've got algorithms. You have to understand computer architecture, both at the gross level and a little bit of the microarchitecture as well. You're doing things with discrete math and continuous math. You have to understand floating point representations and what you can do to a program and still get the right answers. All of these things are really important to get performance. Now, my background working on parallel processing, my goal has always been, or was always, now that I'm retired I can say was, my goal was performance. There's also correctness. It doesn't matter how fast you get the wrong answer. And robustness and debugging. There's a lot of other aspects to compilers that I'm not going to go into a great deal, but it's all fascinating. It gets into a whole bunch of, well, I could go on that forever. So then, what is exciting about working on compilers? Well, let me go into the performance in the high performance and parallel computing part, because we're here at the Parallel Processing Conference. We just had a keynote talk from Catherine Yellick, who's had been at NERSC. I actually don't know where she is now.
Berkeley.
And at Berkeley, back at Berkeley, good. And she was talking about where our computer architecture is going, because of the economic model for the vendors that are building these processors is, well, they're going to build the processors to solve the problems that they can sell to the users. And where is the use case going? Well, there's all these deep learning chips being developed. So all these processors are going to start looking at adding deep learning or AI style processing elements. What does that mean to the other computing users that are not yet into AI? Well, from one aspect you could say they need to get into AI. They should be solving those problems using AI. The other side, which affects compilers, is how can we use those architectures to solve other problems? And let me give you an analogy. 20 years ago, there were these GPUs, NVIDIA GPUs in particular, but because I say that because I have been working at NVIDIA for the past 9 years, but there were other GPUs as well. And they had compute units in them. They could do a certain amount of floating point arithmetic. Now, it was not IEEE compliant floating point, and it was only 32 bits, so not very precise. But there were some hero programmers who said, I've got a problem, needs a lot of computing, I'm going to start writing my algorithm using graphics languages to solve a problem that the GPU thinks is a graphics problem, and then I'll take the data out instead of displaying it on my screen. I'm going to use that for solving a problem. And they were quite successful. Incredibly hard work. I really think that was a good challenge for them. And then along came other folks, computer scientists, said, that's an interesting idea. Can we make that problem easier? Can we design a language to help with it? Well, that became CUDA. And then I took the CUDA tutorial and I said, that's an interesting problem to solve. Can I solve that problem more easily using a compiler? And that became very successful. We were compiling parallel loops to run on GPUs. That was used at the Titan supercomputer back starting in 2008 and 2009, whenever they developed that, and then their follow-on Summit and such computers. So now GPUs and supercomputing are accepted practice. And because the compilers provide the interface to the programmers who are not as smart as you at programming, but they're a hell of a lot smarter at other science.
Yes. So Michael, you gave us a really good reason for why it's exciting to work in compilers. Now, you had a long career with Portland Group and then NVIDIA and such. Some of these people are contemplating different areas that they could work on. So let's talk about, are there jobs in compilers, and will they be able to find jobs in the future in compilers?
fascinating question. So the number of compiler writers that are needed today is actually smaller than it used to be because there are fewer processors.
Yeah.
It used to be every vendor had there were a lot of computer vendors and they all had their own processor, and so they all needed their own compiler. Well, there's only going to be 3 CPU chips left. That'll be x86 for historical reasons, ARM because they're everywhere, and RISC-V. Everything else is basically an advantage. But in the accelerator world, well, that's still the wild, wild west. You've got GPUs, but you have more than one of those, and those GPUs change architectures every few years. You're going to have other accelerators like AI accelerators, and there's a serious possibility that with advantages, with changes in the way that chips are designed, that someone out there will be able to design custom chips, organizing the processing units and the compute units in a way that would solve their problem more effectively, to have a custom little chiplet that would then get put on the same substrate as a processor chip. And now they need a way to use that. So are there jobs for compiler writers? Well, if you're into the boring part of the compiler world, which is C++ compilers for RISC-V, that's going to be mostly open source. Yes, there are jobs there. All the vendors are going to need to make sure that their processor is well supported, that you can get performance out of them. At the more exciting end, if you want to start look at the high performance and parallel computing world, this is where I'm coming from, there's going to be unlimited demand for people going into that.
I believe, and you talk about one aspect that is very important, right? The compilers are adapting to the architectures that are being produced. There's the other end too, that is the proliferation of programming language that bring new challenges.
Oh, yes, right.
So,
absolutely,
so
yes.
okay, so thank you very much. Very nice chatting with you here.